Welcome to another video for organic chemistry. In this video we're going to be discussing the Hammond Postulate, which states that the transition state resembles the structure and energy of the reactant or product that is closest to it in energy. Okay, so we're going to be looking at it in two ways, the structure and energy signature. Okay, so here we have a energy curve, okay, a reaction pathway for a second degree alkyl carbocation, which is signified in the green, and a third degree alkyl carbocation, which is signified in blue. Alright, so if I look at this particular reaction that I've looked at in other videos, remember I have a hydrochloric acid molecule that I'm combining with the propene. So my hydrogen and chlorine will separate, and my beginning reactions, or my beginning reactants, as you see, are signified by our letter A in our energy curve. Okay, now it jumps into a more unstable state where when our hydrogen will bond with one of our carbons. So that double bond that has maintained the stability of the molecule will now be broken. Okay, so now it's become more unstable, and that bond is broken, and it's halfway now forming with hydrogen and halfway broken with the carbon. So it's a very unstable state, and this transition state resembles our A. Okay, it resembles A far more than it does C in structure and in energy. Okay, so once this double bond has broken, okay, that delta positive that you see by our hydrogen will then balance out and will transition then to our middle carbon there, our 2-degree carbocation. Okay, so let me step back. So the double bond breaks and a new bond with hydrogen is made, so it becomes a little bit more stable, but still not stable enough. So we now go to transition, our intermediate transitional state, our carbocation state, and then here comes along our halogen. Our halogen will then create more instability by almost creating a bond with that second carbon. So that delta positive, that positive charge that that carbon has, will begin to dissipate and will begin to balance out with the electrons that the chlorine will donate. And take notice that this transitional state resembles more our C than it does our A. It resembles it in its structure, and it will also resemble it in energy. So notice what happens to that dotted bond. It will complete, and now you have a solid bond, and now you have its most stable product state. Okay, that the halogen and the hydrogen have now created complete bonds, and this molecule, this Markovnikov addition, is now complete. Okay. Now I'm going to go ahead and gray out our green line, and you can see that we have a blue right underneath it. This blue line is the energy signature for a third degree carbocation. And remember, third degree carbocations are more stable than our second or even our first degrees. Okay, so notice how that blue line lies underneath our green, signifying it's more stable than the green, the second degree carbocation. Okay, so it's a more stable energy curve and a more desirable energy curve. So that does it for our Hammond postulate. Again, this states that the transition state resembles the structure, so we look at the structure, and the energy of the reactant or product that is closest to it in energy. Okay, so thanks for watching. Good luck in your studying.